Hi, this is Miss Park. Today's video is called Parent Functions. I'll direct you to this page uh, from the booklet, and this page is basically a list of our parent functions that we are going to transform in this unit. So I'm going to start with the first one. The first parent function that we're going to work with is all too familiar. It's the quadratic function from grade 10 and from previous units. So let's fill in this table of values for the quadratic function. So I'll start with some x values, -2, -1, 0, 1, and 2. That's our standard basic values. If we calculating the y, so all it is the x value but squared. So -2 squared is 4, -1 squared is 1, 0, 1, and 4. And if we go and plot these points, and I get one here, 0, 0, that's our vertex. There's one at -1, 1. There's a symmetrical point at 1, 1. Then there's -2, 4, and also 2, 4. And the reason I left this blank is because I know this grid can actually accommodate another. So let's just put another. So if I add these ones, then this is a 9, and this is also a 9. And so I've got a point up here, and I've got a point up here, and this is my quadratic function. And every time we graph something, we're always going to label the graph with the equation. So usually near the arrowhead, we do that. Okay, next column, what are some features, special features in symmetry? Well, certainly it has symmetry. So every quadratic function has an axis of symmetry. Okay, the axis of symmetry of this one is the y-axis, which is the line x equals 0. Once we start transforming the parabolas and moving them around, the axis of symmetry will not be x equals 0, obviously, but for the parent function, it is, right? Parent function is just your plain old basic vanilla function with nothing, no transformations done to it. Okay, the domain of the quadratic function, so just a quick review of before. This parabola goes forever from side to side. So the domain is the set of all x's such that x is an element of the real numbers. Okay, not the same for the range. So you can see that the lowest y value, the minimum, is at 0, and then the parabola is above that. So the range is the set of all y's such that y is greater than or equal to 0, and y is an element of the real numbers. Okay, so that's your first parent. The next one on your sheet is the cubic function, x cubed. Now, we don't study x cubed in grade 11. We actually study it in grade 12, advanced functions. So if you're curious to see what x cubed looks like, by all means, fill in this section here, but I've crossed it out because it's not something that you're responsible for in grade 11. Okay, the next one is, this is called an exponential function. It's 2 to the exponent x. So we've never seen before a function where x is in the exponent. Usually x is the base, right? So we'll be studying exponential functions in detail in a future unit. So I'm actually going to skip it for now. We are responsible for it in grade 11, just not in this unit. Okay, but we will come back to it for sure. So let's go to the next page. Okay, the next one, square root function, or in other words, radical function. You can imagine, since we took some time to learn about radicals, that this is one of the functions we need to know in grade 11. So I'm going to give you some numbers. So I'll go -4, -1, 0, 1, 4, and 9. And why did I choose these numbers? You just give you a second to think about, why did I choose these numbers? Why did I not go 1, 2, 3, 4, 5? Okay, so to calculate the y's, I need to take the square root. So I've conveniently chosen numbers that are perfect squares so that the y's will be whole numbers. So what is the square root of 0? It's 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. You'll notice I'm not saying plus or minus 1, plus or minus 2. That is because that radical, that means it's the positive square root. Okay, we're only talking about positive square root. There's nothing in front of it, so it's just a positive square root. What happens for -4 and -1? Well, we can't take the square root of a negative number, so that function is not defined there. I'm just going to X it out. It's not defined for those values. So our first point is at 0, 0. Our second is at 1, 1. Then we have 4, 2. And then we have 9, 3. 5, 6, 7, 8, 9, 1, 2, 3. And that's what the radical function looks like. And every time that we graph something, we always write the equation, sorry, this is f of x equals square root of x. Okay, are there any special features here? Is there symmetry? So there's no symmetry, but special features would be the function is not defined everywhere, right? So it's not defined for x less than 0. This is the first time that we've seen a function that is not defined, right? Lines will be defined everywhere. The parabola is defined everywhere. So it's the first time that we're seeing something that's only defined on part of the grid. Domain. So the domain would be the set of all x's such that x is greater than or equal to 0, and x is an element of the real numbers. And range is the same. The range is a set of all y's such that y is greater than or equal to 0, and y is an element of the real numbers. So again, domain is everything larger than 0. Range is everything larger than 0. All right, here's another important one called the reciprocal function. So this one's all new. And so I'm going to give you some numbers for this one also. So I'll go -4, -1, -1/4, 0, 1/4, 1, and 4. Okay, now it may seem funny why I chose those particular numbers, but just bear with me and hopefully it'll make sense why I chose those. So to calculate the y, it's 1 over -4. So that will be -1/4. And then 1 over -1. So that's -1. 1 over -1/4 is 1 divided by -1/4. So that would be -4, right? 1 divided by, that's multiplying by the reciprocal. So multiplying by -4 over 1. So you get -4. 1 divided by 0. 1 divided by 0, well, that's going to be undefined. I can't do that. 1 divided by 1/4 is 4. 1 divided by 1 is 1. And 1 divided by 4 is 1/4. Okay, so let's try to plot these points and see what we get. So at -4 we have, so we're going to have to kind of estimate here because we can't put in these fractional points. -1, -1 will be here. -1/4, -4 will be here. All right. At 0, there's nothing. 1/4 and 4, so 1/4 and 4 will have a point. 1 and 1 will have a point, and 4 1/4 will have a point. Okay, and now we get these points. So how do we connect these points? If you put in numbers that are smaller than -4, let's say you put in -10, then what you're going to have is -1/10. You'll have a y value that is very, very, very small. -1/10, very close to the x-axis, but it will never touch the x-axis. Even if we go -1000, we'll have a number that's really, really close to the x-axis, but it will never be the x-axis because the y can never equal 0. You have a fraction here with a 1 in the numerator. The only way a fraction could equal 0 is if there's a 0 in the numerator. The fact that there's a 1 means doesn't matter what we put in for x. If we put really large values for x, we're going to get close to 0, but we'll never actually be at 0. So what ends up happening is this part of the graph ends up coming really close to the x-axis, but never touching it. Similarly, on the other side of the graph here, if I pick really tiny values of x, like negative 1/1000, then my y's is going to be negative 1000, which is going to be a very, very, very large number. Okay, but I'm never going to be able to cross this y-axis here because x can never equal 0. We said if x is 0, that fraction's undefined. So I'm going to do the same thing on the positive side. If x is a really tiny positive number, you get a very large y number. And if x is a very large number, then you get a very tiny y, but never 0, right? The y will never actually be 0. So this ends up being the graph. I'm going to label it f of x equals 1/x. And what ends up being created is two very, very special lines. So I'm going to get my ruler and I'm going to draw on the x-axis and the y-axis. And I'm going to tell you a special name for these two lines. So here I am drawing on the x-axis. I'm going to label it. This is part of my graph. This is the line y equals 0. I'm going to draw on my y-axis. This is the line x equals 0. Okay, and those lines are very, very important. They are called asymptotes. You're going to need to know this word well because we're going to use it a lot. Asymptote. And an asymptote is a line that the graph comes infinitely close to, but never touches. That's the asymptote. And so for the parents, there are these two asymptotes, x equals 0 and y equals 0. Okay? It means that if I go further in the x's this way, the y's will just get smaller and smaller, but will never hit 0. So the graph kind of hugs these asymptotes, but never actually touches them. Okay, so those special. All right, so let's talk about domain and range. So what x values are allowed to be on this graph? If you look at my table of values, what could I have put in for x? Well, anything except for 0. So we write the domain is a set of all x's such that x is not equal to 0, and x is an element of the real numbers. And where have we seen x is not equal to before? Right, in restrictions. So that will make sense that this fraction has a restriction, right, from the previous unit. Same thing with the y's. Y's are going to be anything except for 0. So it's a set of all y's such that y cannot equal 0, and y is an element of the real numbers. All right, that's your reciprocal function. Finally, there is the absolute value function, which I've also crossed out because it is a grade 12 function. So you're not responsible for it. But once again, if you're curious about absolute value, please do this just for fun. The explanation here tells you what absolute value is. Basically, absolute value is the size of the number or the distance from 0. So if the number was 5, the absolute value of 5 is 5, but the absolute value of -5 is also 5. So it's the size of the number without the sign, or the distance from 0 of the number. And then you could try and plot it and see what it looks like. All right, so for the rest of the unit, we're going to be transforming these parents. So just quick recap, what are they again? They are the radical. The quadratic. They're the quadratic, the radical, and the reciprocal. All right, thank you. Thanks for watching.